Alright, welcome back to linear algebra. Let's jump into Anki. It is not true in general that a matrix product AB is the same as the matrix product BA. State three ways in which the equality can fail to hold. BA and A are AB. Say they're different sizes. They are the same size, but the corresponding entries are different, and one is defined where the other isn't defined. How is the inverse of a product of invertible matrices related to the inverses of the individual factors? The inverse of the product. So the inverse of the product equals the inverses of the factors in reverse order. All right, that's it for Anki. Let's go ahead and return to grading what I did yesterday, and then I'll be back to see how I did after that. All right, got the problem from yesterday correct. I'm gonna keep working now on more practice problems. I'll be back to call what I did in a little bit. All right, just worked on one problem the entire time. Let's try to recall some of this so I can lock this in so I don't have to spend all this time doing something like this again. All right, we're meant to express a matrix, this matrix, and its inverse, this, as products of elementary matrices. And so what I did first was find the inverse via Gauss-Jordan. Is this Gauss-Jordan lineage? No, this is like some method using elementary operations. And what I did once I found this was I took basically the the elementary matrix that would perform this operation times the -1 by the second row and add it to the first row, and then I did this this elementary operation, then this elementary operation, this elementary operation, and then I multiplied them out and found out that this is actually the inverse of A. And now I'm trying to figure out how to express A. So you express the inverse of A the inverse of a matrix as a product of elementary matrices by starting with the matrix, finding the elementary row or elementary matrix, starting with the matrix, finding the inverse of the matrix, and then basically multiplying each matrix backwards that you did to get there to get the inverse. Then I thought you could just flip the order around and find A, but that's not how you do it. The next thing I'm checking is basically like taking the opposite of each of these. So if you take -1 times this row, I'm saying +1 and add it to this row. That would undo it. So I'm doing the matrix operations that would undo the things that we did, and I think that we'll be able to figure it out, or be able to express it. Well, we're gonna find out that tomorrow, and if I can't figure it out after that, I'm just gonna look it up because I spent so much time on this problem. So that's it for today. Talk to you tomorrow. See ya.